Oh,
Hey, Marcin.
hey, I hope you can hear me.
Loud
We
and clear.
can.
Okay, cool.
Sounds like Brandon is not on a bicycle this week. Need to talk bikes with you sometime, Brandon.
Indeed. I found that pretty funny.
Are you going to be on the conference circuit at all this year, or now that you're retired, are you leaving that life behind?
I'm going to scale it way back.
Well, if you make it to Open Source Summit or Container Plumbing Days next month, we'll be there.
Those were on the, would have been nice, but didn't quite get on the list.
Oh well, I'm sure there'll be some time we run into each other in person and have some time to talk about it.
Those are probably my two favorite conferences.
I'm just excited that I'm not, I don't have anything conflicting with PyCon this year because like of all the had my work obligations collide with my ability to go to conferences I enjoy personally. But this is like the first year in a while that I don't have that conflict.
I will say the fun part about doing the bike ride on a conference call is that I'm probably staring at some of the buildings the call is going through as I'm riding through Data Center Alley.
Right, I forget what neck of the woods you're in.
Yeah,
Closest I get to that is on a uh, on a bike trail or well a bike path ride out here. You can ride past the NSA's data center, just 10 miles.
that's a fun one. Yeah, there's a whole bunch of them that have US government warnings up here. They don't tell you which part of the government. There's like, yeah, we're the government, undisclosed, unlabeled. Don't come over this fence.
The old login to do my tax or to submit a tax return, and you were accessing a U.S. federal government information system. Unauthorized use will be prosecuted. Like just the very generic like government website warning. Yeah,
We're good at that
looks like
over here.
this. Looks like this might be who we have this week.
I thought we might be getting Vanessa, but she was also up late.
Oh, we can wait 1 more minute and then we can start.
And in the chat, apparently her Zoom crashed. There she is. Okay, now we can kick it off.
Okay, then let's start. So the first item on the agenda, let's talk quickly about received feedback so far. Because with Vanessa, we're asking a few people about this, what they think about those all proposals and so on. We also reached Containerd maintainers to express their opinions, especially Phil and Steph. I'm not sure how to pronounce his name, Stefan, right? maybe I will just write on chat. Sorry, I'm not native. And their first, when they read that and they saw the spec and artifact and all of that, they said this is very complicated, and the reasoning behind why we put a graph inside the spec is not quite understandable to them, and they said because it's artifact and the way of its complexity, it will be hard to integrate that into container runtimes. They have a good point. However, we over the emails we had discussion with them, I expressed an idea that we can basically provide some pluggable mechanism that community provides their own image selection algorithms, that this kind of stuff is not part of the core implementation. And also we have some good arguments why we need, at least from my side, why we need to have something similar to graph or graph itself on the spec level, which should be basically optional, because I understand that not everybody would like to have or need for complicated relations for their compatibility. But the meeting is tomorrow. It is 11 a.m. PST, I think. So if anybody would like to join, just ping me and I will send you invitation to this discussion. It's gonna be mainly about how we can incorporate this compatibility stuff into container runtimes, basically container D right now. And we are going to talk further about the requirements we express. There's also another feedback from other people. Basically, they understood the need of graph and so on. So this is the first item in the agenda. I just wanted to talk quickly. If you would like to join the discussion tomorrow, just ping me and I will send you invitation. And then let's talk about schema and spec for the final design. So I will share my screen and let's talk about that. Screen 2, screen 1.
One thing I'm interested in are the use
Yeah.
cases where you are sure that you need a graph in the spec. Because I'm wondering if we can still have a graph, but either represent it in a simpler way so that the person creating the artifact doesn't need to write a graph. Or if it's some kind of truth, like, well, in this case, you can either use this device or this device, and that is some kind of truth, and that would actually go in like the schema graph. But
Well, it's getting very complicated because I wanted to share with you specific Huawei examples, but I'm not allowed to because this is confidential about the hardware.
can you
they
just
are
like
using.
change the names and like make it up a little bit? Be like, this squad needs marshmallows that are toasty, but it could use marshmallows that are roasty or something.
Sure, I could do that. I'm not sure if I can do that because I would. I mean, I'm not sure if I can do that right now because I would have to edit the whole sheet I received. If the meeting wouldn't be recorded, I would be able to show you this stuff. But basically, the reasoning behind graph. So imagine you have a situation where you have a software that is very dedicated to the specific NIC, and you can have multiple those network interfaces card, and all of them have like either they can support SRIOV, they can support OVS kernel, and they can support user space drivers and so on. Then there's a lot of combinations you can do over those stuff, and it's based on the hardware. And even if you add all of this stuff, how you enable, like for example, SRIOV or IOMMU and so on, which is related, you have different way of enabling that on the Linux, right? So if you have inter CPU, you have different options, and you combine different kernel modules or whatever for the specific NIC. And then you have another NIC, and it can be on the AMD CPU instead of Intel. And then you have another options how you enable stuff. If we don't put this into graph, you end up with a big list of multiple supported NICs which repeat themselves in terms of, for example, in how to enable IOMMU. So instead of repeating those stuff, it would be better to put these informations into nodes and connect them somehow. Is it clear? Yeah.
I want to kind of try to connect all the ends together here. What's the workflow you are envisioning when you build this graph? How would you take a container image you've created and say, let me attach this graph to it in a way that someone else could later on use that graph.
Sure.
So, because what I'm thinking of is you might have a build machine that has a bunch of stuff on it that is completely unrelated to what the application itself really needs to do its job.
Is it that way? If it's unrelated to the application that's doing this job based on the
I
hardware?
mean, I might have a build server that has GPUs and all this kind of stuff because I might be doing different builds, and some of the builds might need a GPU, but a bunch of the builds don't. And so how do I say that, yeah, I built it on this big beefy machine that's the Intel quads,
Yeah,
all the different tools. Go ahead.
basically, because for example, in the telco data center, you have like a lot of machines with different NICs based on the different agreement and SLI level and quality agreement level as well. So one application can support a specific network card and so on. And you have to somehow express this for the application if it's going to run on those specific machines or not. And the way how you do that, I thought you basically have a compatibilities list like here. And
this is like those profiles. Remember we were talking about profiles at some point? Kind of.
Forgot. but yeah, kind of profiles, right? That I mean, you specify a list of compatibilities. Those can be, for example, NIC with chipset Intel, NIC with chipset Mellanox, and so on. And you can have support for Intel CPU and AMD CPU. And later, basically, you connect everything in the another field, which is optional, like relations, and you build a separate graphs how they connect. So, for example, once you have two graphs in here. You have a graph that starts with Intel and starts with AMD. So once you have AMD's Intel CPU, you connect to virtual functions kernel modules, and you do the same from AMD CPU. The difference is like for Intel, you have different set of command line for kernel, and for Intel you have the same. So the difference is for Intel IOM you have command line Intel IOMMU on. For AMD, it's AMD IOMU PT.
Yeah, so I would argue this still goes in a schema graph. Because and then the way that you have them with IDs, those IDs would become one of the levels in the attributes that you're describing.
But
And
you cannot do this on the schema level, because schema level is controlled by the interest group, the authors. So you would have one way of defining the graph. So for example, if
but why couldn't you make a schema that you control for your telco or something?
Yeah, but if you build a schema for telco, you have a lot of combinations and variations, and then can exclude each other. So it's impossible to build such graphs, because one person would require a specific NIC with specific requirements, and if you build based on that the graph on the schema level, and another person is coming and will have contradicting requirements to that, because it's possible based on the hardware and the features and so on, it's gonna be quite hard to do that. And I think that is, if it's on the schema level and you'd like to put all the variations of everything, it's kind of very long list how would you build this graph on the schema. I was talking about that on this because if something is not clear, maybe it will be more clear about how I describe that in here. But on the schema level, this has to come up from the user's perspective. The graph that they are building is coming from users, and those graphs are small usually, but they have to control their compatibility, which is basically the outcome of the application itself.
Okay, so that was kind of where I was going to with the original question was, how are we generating this? And if it's saying, okay, a user needs to manually generate this graph for each one of their applications, I understand where you're going. I can envision people wouldn't be happy with it, but I understand where you're going there, because the alternative I just don't think is feasible, right? If I was to build Nginx on a server with a certain NIC card, Nginx is still going to run on any other machine with any other NIC out there. It doesn't care. And so I think we need to be careful of overfitting is the concern I have.
Yeah, that's correct. That's why I want to make this optional, because I'm aware that 99 maybe percent of users or 90% will not use that, and they don't need that because those requirements are quite complex and are addressing specific groups, right? And because if you run container on the user level and you connect the NIC to container itself, and you somehow provide the software for this NIC in a container, then you fulfill the need for NIC. Kind of like, it's not some kind of abstraction that doesn't touch the application. My point is your stuff with Nginx. We are not running some, I don't know, website that doesn't care about what's running under the hood, that you can move application container from host A to host B or so, because those are very, very specific problems to solve.
Patrick has his hand up too.
Yeah, my hand doesn't get tired in this this business following it up, but I was a little bit also concerned with like overfitting and going down to details, but with especially IO MMU, because I mean I normally it's just on. Okay, let's not talk about that, but I was thinking that okay, this when you have the set of compatibilities, or actually the where you define like Intel CPU, AMD CPU, and so on and so forth. Okay, that's actually needed for a shorthand, because you need, otherwise you repeat all these lines very many times. But then if you scroll down a little bit, where you start to say that this is a graph, here I think this sort of I'd envision the bigger panic hitting in that ooh, this is a graph or whatnot. How about instead of actually having graph and pointing edges, isn't this more or less that we have, if you just list things here, they are ANDed together. So when there is actually something that's compatible with each other, it's basically some kind of a one-off relationship, and then you would in that that bracketed space, you would then list up the things that which one of which that can satisfy the conditions. Because I mean, I think that's actually what the graph is doing.
Then you will have a false positive result, I think, because I could just remove this graph at all, and if I understood you correctly, if I would just go through the list and check what is failing and what is not failing, and maybe like stuff like, for example, I have Intel CPU and AMD CPU. Intel CPU is kind of okay, right? It's passing. And you have different set of compatibilities that by accident are positive on the host, and you can end up with some kind of false positive result. If you know what I mean, or should I elaborate on that? Or
please elaborate a little bit more, because I was thinking that actually you could make a relationship, basically an OR relationship between the AMD and Intel CPU, and that's one OR. And then actually, when you have the different GPUs, that means that you actually are happy with either Intel GPU or NVIDIA GPU or another NVIDIA GPU.
So we would have first AMD Intel, then you have, for example, GPU NVIDIA, Intel, and what would be the another one? AMD. So if I have AMD right now CPU, which is OR, and it's passing, it's fine. And then I would have like to specify that AMD CPU, and I would like to have only here NVIDIA GPU. So if I'm hitting some Radeon, this is just theoretical theory, right? So if I'm hitting here that I have a host, let me put this more clear, host with AMD CPU and AMD GPU, that is okay, right? This is what I want. And then if I have a host with AMD CPU and NVIDIA GPU, I say I don't support that. But if I go with OR right now here, AMD CPU, Intel CPU, okay, and I have AMD CPU with NVIDIA GPU, then you end up with having success, which is a false positive in that case, because it's just one of the possibility that passes. However, this graph, I mean, not.
Yes, but
But
then
aren't you
actually
taking the host information into account? It's not like a blind choice without actually considering the different labels with considering the hosts. I mean, that's
Because
sort
that-
of the assumption, isn't it?
I was like thinking here that then you actually, your condition is AMD and NVIDIA is one of the choices, and then and then comes a parenthesis Intel and something else.
Ah, so you just wanted to build possible choices, right?
Yeah, I mean, yes, if you say AMD or Intel, yeah, okay. If it's just the CPU that is the problem here, then we can choose either AMD or Intel. And if
And
the
isn't-
graphics card doesn't
sorry.
make any difference, then you list them all. But yeah, I mean, either. But if you actually need both, you need AMD with something, and then or an Intel with something else. Then actually you have to do a little bit more so that you express the conditions that you actually want. I'm not sure if is this going to. I mean, because what I have been hearing so far, at least in this working group meeting, yeah, with NVIDIA there can be a lot of choices, but actually when you sit down and start making your images, you still want them to be pretty minimal. So I'm not sure you have too many choices for one image. Maybe a few. Maybe if you have like, I don't know, AVX something, then you could actually go for the lesser accelerated commands, but not so many, because I or do you actually see that you end up with like choices where this would explode and a graph would actually make it more compact? Because I'm not sure. After listening to Vanessa explaining about NVIDIA and user space libraries and whatnot, it sounds a little bit that they are pretty trimmed down to very few specific choices in the end, and then actually your other image contains the rest.
Yeah, I understand. I understand already. I would have to check this if that would pass our use cases, but I'm aware that graph sucks basically.
They don't suck. It's just too complex to put in and have under the control of the user. Because as Patrick said, you're scrolling down and you get to the graph and you're like, oh my god, like this is not what I want to be writing or trying to parse in my brain right now. Okay, I have a really stupid question.
Yeah.
These are truths about your host, or these are truths about the application in the container?
Application in the container, and based on that you have to execute some plugin, that extractor in your case, that will get host information and compare what is in the compatibility specification to us to check if it can pass or not.
So you're saying your container is able to support 3 kinds of GPUs?
This is just theory. I would prefer to talk about NIC, but I cannot share so much information, unfortunately, about that right now. As I said, if we wouldn't record, then I would show you the.
Okay, so your container can support 3 kinds of NICs.
Yes, because in terms of
and what about what's on your host? And your host has also 3 kinds of NICs?
Nope. You have a big data center with different hosts with different NICs based on the performance.
So on one host, there's one NIC type.
Yep.
So why wouldn't it be the case that you get that particular host and then you look for that particular NIC and you don't care about the other one?
But I need to store some information somewhere about all supported NICs by the application, because application is very picky about that.
So why wouldn't you just have 3 entries that say like NIC 1, NIC 2, NIC 3, and then your that particular host would find that NIC and be like, okay, this is good. It would look for the other specific things that it needs.
I'm not sure how exactly that would look like.
You would need so is the issue that you want to be putting basically 3 different types of NICs in one basically metadata attribute?
Yeah.
So why don't we just find a simple way to do that instead of adding a graph?
Because the way you have different parts involved as well, not only NIC, because you have different kernel features, SRIOV, kernel OVS. You can run network card drivers on the user space, not on the kernel level.
But again, the host knows what it wants and needs, right?
But we don't want to describe the host. We want to describe the container, what it requires.
Right, but the container, I guess, like, okay, to me, this kind of smells like what we were going into earlier, that is like a profile. Because if you embed like the specific graph here, kind of to go back to what Brandon said, like if you pull it down on a really just different machine that doesn't care, like it's overfitting for your particular machine. That's what it kind of feels like. So we have to find a balance. Like, how can we have the metadata attributes that will provide enough information for something that maybe smells like a profile that has these details, without kind of not forcing it, but without having to put this graph into the spec. Even for an advanced user, I think this is too complex for a human to have to manage. Go ahead, Brandon.
I'd also look at this and try to step back. If you've got 5 different NIC cards that you're supporting with an application, is it because all of those 5 NIC cards have a certain quality? And maybe you could capture that higher level quality instead of the individual NIC cards.
Yep. Yes. Basically, that's right. And certain features and certain custom software as well, because you can have NIC, which is doesn't come with the software itself, and can be programmed by telco engineers. Like, for example, it can solve only hardware without firmware, and like engineers from telco company can adjust this to their needs or write their own custom software that will process everything from the card. So basically, it's very picky about the NIC. And if you follow the Vanessa's idea about describing from the host point of view, we have to include, because it becomes a matrix that you have list of NICs, list of CPUs, and hosts that support specific features. NICs by supporting specific features. So for example, you have somehow support, let's say, just an example, NIC 1 on AMD with SRIOV. You have one way of enabling that, and you have the same NIC on Intel CPU and different way of SRIOV enablement, right? So this kind of issues we have to solve. So that's why the first thing that came to my mind was a graph.
I guess this is an interesting, strange case, because most containers that I guess normally when I build a container, I build it for a small, like a very specific, like it's intended for a very specific environment. It doesn't have every flavor of GPU or every flavor of NIC in it. And I'd also step back and then ask, what percentage of use cases is this solving? Because arguably, if we're making a specification that's going to be standard for like the container world, we should be considering even like 80% of users, that it satisfies that. And if this is really only 1%, then if we're basing an entire design on the 1%, I'm not sure that's a good decision.
I'm not sure how to calculate that, because telco is quite big and you have many companies in there. They have quite big data center. But the problem is right now, they found out that this is a problem because they are moving from OpenStack to Kubernetes and all of this stuff. They are moving from virtual network functions to container network functions. And telco applications can support like not everything, like from the NIC perspective, but they run quite strict benchmarks of the NICs that they are being supported. So one application can support, let's say, 5 NICs that has been approved with different chipset and with different with different features, right? So, and the deals how sometimes are made in telco are kind of because they have big data centers and require high SLA and so on. So that's why you end up with different chipset, and maybe one application can cover OVS kernel path and other node, but there is another way of providing your own stuff and so on. I know it's kind of
You could still though have like a flat list of metadata attributes and then a specific profile on the host. This is what I need. Look at the attributes, go down the list, figure out if the combinations and the graph logic is there, and not put that in the artifact.
but then you put source of truth on the user, right? Because how would I figure out that? I mean, how as a user that wants to verify this compatibility, I have to go to that host and provide kind of information what I have.
That's what the scheduler is for. So this is common in HPC, and so like with the design that we're doing right now, so I'm building a custom scheduler that does this. And the first thing that does when a cluster registers is that it extracts node level metadata. So it actually extracts everything about a specific node, and then the node gets added to a cluster graph. The cluster graph goes to the scheduler. The scheduler knows exactly the details about each particular node. And so go ahead.
So if I understand correctly, I would just put a simple list of everything that my container supports without specifying any relation. And I go into host and execute that. They have some plugins that extract information about the host and see if there is a matching. So the responsibility is kind of the other way around. I don't specify the source of truth on the compatibility manifest. I just take what's on the host and compare to the compatibility manifest to see if I have some positive results.
The artifact would basically be a list of like, this is what the container could support. And then the description of what actually is on each node or each host, that would belong in that graph. And then basically the logic to match those two things would be kind of a collaboration between the scheduler and image selection, because the scheduler is going to basically do a filter that says like, okay, I'm going to, run this particular job on this node. Then when it actually hits that node, depending on how you're pulling the image, then the image selection would arguably then pull a filtered set based on what the scheduler has chosen, the URL, the image that the scheduler has chosen.
I'm just worried that we might hit by that some false positive results. I cannot think about examples right now, like other than.
Are you able to do like experiments to kind of test some of these ideas?
Yep. I'm going to do that. But
yeah, one other observation I have is that like what you're doing seems to make sense for like the tightly validated world that you're living in. But like I struggle a little bit with like, I mean, certainly I think there would have to be more trivial examples, and like how like niche of a niche use case that is, I think would have to be highlighted. Like in a world where this is widespread, I do fear a lot of vendors are going to overly constrain the quote unquote compatible hardware. And especially if scheduling decisions are attempted to be made, like lead to a world of painful fragmentation and, even like unnecessary non-extant vendor lock-in. Like it sounds like, there are very real reasons in your neck of the woods to like say, this specific like PCIe device ID is the only thing this container should be scheduled on, but that's not true for 99% of the cloud world. In fact, that's actually kind of the point of a lot of so-called cloud native technologies. And I definitely see the temptation of I am X vendor, and I've tested on Intel, so I'm going to put that only these Intel chipsets are good, or like Intel gently tries to incentivize me to ensure that like we're only saying that our application's certified to run on their CPUs. Like I don't know. There's a part of me which is just really kind of repulsed by the like level of granularity expressed here, simply because I think we've all experienced like that gone wrong at some point in our careers.
Yeah, I understand that. I get your point. Yeah, I'm just trying to find the best solution for our use cases in here. And also I think about the community, right? That's why I wanted to make this optional. But I understand your concerns. When I see this graph in the spec, I'm also terrified by that, to be honest, but didn't find, as I said, better way of expressing this kind of use case. So yeah, what I'm doing next. Sorry, go ahead.
Yeah, because I do understand what you're talking about. I used to work for Nokia, so a very long time ago, mind you. So it wasn't even close to any containers at that point. But I know how picky they are with their hardware. I'm just wondering, I mean, I wouldn't like to scare people away with having them write a graph to do this. The other question is that if you actually specify, I mean, figure out what the set of truth is for your particular cases, and then you say that put an OR in between all of those that actually are then compatible and not the other ones. So does it, I mean, to me it feels that that wouldn't scare users away from this spec. But does it mean that you actually end up generating how many 10,000 lines of specification in that case?
Yeah.
Because at some point I would come and say that, hey, maybe you need to actually split down your images that you are trying to provide, because at some point you have so many choices that nobody can actually do any scheduling in like proper time intervals anymore. So at that point you have to probably reduce the complexity anyway down to something that's manageable. But I don't know. Because I'm not sure now that do we have like 10 nodes in the graph, or do we have just 3?
Yeah, it can grow. Like basically what you would have here. Those, as I said, you would have multiple hundreds of nodes or like 50, but 10, 15, something like that.
I do want to kind of hit on Nathan's comment of the compatible versus optimized and kind of put this into perspective of some of the other stuff that's going on in OCI right now, where we're looking at supporting more than just one variant of AMD64 right now. There are multiple variants, and part of the logic in that is that if you're running an old version 1 AMD64, you can't pull and run the version 3 AMD64 images. They just won't work on your machine. They're going to be calling stuff that just doesn't exist on your CPU. And so I want to be careful we don't, or I think there's value in what we're doing here to focus on this is what you need to actually run this container, not what you're going to use to get the best performance out of this container.
But yeah, that's a really good point.
But I have some kind of counter argument to that, like because compatible, it depends from the industry what it means to be compatible, right? If you don't meet appropriate performance of some specific applications, it means it's not compatible. It's not only about running on the host or not. If I got your comment right.
I do think there's a line though. So in some of my early experiments with just image selection, what I basically did is I had different sets of these attributes that would describe my application, which was lamps. And I did different cases where I would basically use different sets of them to decide which image to run on which particular host. And it was interesting because I found that there was a minimum set that I needed that I guess up to that set, like if I didn't have it, I would have cases that wouldn't run. And so that's an issue. To me, that's an issue of compatibility because I chose poorly and I chose something that absolutely wouldn't run, and that's what you don't want. But when you get to this minimum number, all of a sudden, everything runs. It doesn't mean that it runs well. It just means that it runs. I had huge variability because of the MPI that I was choosing. Then when I tweaked it more to add in information about MPI, that's when I got better performance. So for me, that's where it switched from, okay, compatibility into running sort of more optimized. And I think what this discussion is highlighting is that there is some kind of transition there. And I think the question is like, where do we put the algorithms that are needed to not just make it compatible, but to make it run optimally? And I don't think I have the exact answer to that question, but I do think it belongs somewhere in this scheduling process. So for example, I'm designing a scheduler now that will take custom algorithms like this. And it could be the case. I don't know how these working groups work, but maybe we can come up with a simple design first that doesn't kind of assume this sort of hard-coded, a little bit overfit complex case. Do more experiments actually with the scheduler and then come back if there's a demonstrated use case that something is absolutely missing that we need to add that cannot be solved with plugins or profiles or schedulers, because my gut sense is saying that this problem can be solved without doing this. But I can't give you like what that looks like at this exact point. Okay, everyone has their hand up. Just everyone go ahead.
Sorry, I was first, so I will go first. To answer the first part of what you said, in that case, because I would agree with you if that would be last kind of fine-tuning the operating system or so, but you have really strong factors like hardware. You cannot just if for example the container doesn't find a specific piece of hardware, it means it's incompatible, and you cannot do it about that anything, because the assessment if this gonna be optimized or not is one layer higher, but you are picking a specific NICs based on the performance, meaning if it's optimized or not, and you cannot bring any algorithm that would kind of assess if this is compatible or not, or this is just optimized, because we have really hard facts here. You have a specific hardware, and you have just bunch of hardwares that are compatible in that case. And that's just my comment. So maybe I think Bjorn was next.
Yeah, I mean, I think this goes actually back to my observations before we even, kick this group off of, one, I think there's a lot of places in the life cycle where this information can be organized and actioned on. And I think that certainly, like, I was one of the people kind of pushing strongly for, like, I think at some point the scheduling layer has to be involved. And it's interesting to see people come back around, because, like, not just image selection, right, but even like where the jobs are scheduled. That being said, like, I think the kind of like a bit of the disconnect here is that there are just very different perspectives we have, like versus Marcin. We'll just say, like, Marcin's like in this, like, do not pass go, do not collect $200 world. And then, like, my perspective, like as a more of like a ersatz image author and runtime maintainer, is that one, I can usually author a generic image that can work anywhere, and then I can make better versions of that image. So, like, an example here, let me pick on Torch. I can have Torch with CPU, with the CPU runtime, but then I can have an NVIDIA version of Torch that requires CUDA, or an OpenCL version for AMD. And then, I want I want to fall back to the CPU version because that'll run anywhere. Obviously, like, on the one hand, not super useful, because presumably I have all these expensive accelerators and, like, I want to use them. But on the other hand, like, for a certain value of work, it will work. And that's kind of my perspective, right? Like Brandon's point of, like, I can fall back to a more primitive, non-vectorized set of CPU instructions if I really had to, and it will run anywhere. But of course, if I have the higher end hardware with modern instructions, I want to take advantage of that SIMD and whatnot. I mean, I think my main observation here is that, like, Marcin is in this, like, go or no go, do not pass or do not pass 200, do or do not pass go, do or do not collect $200 world. And the rest of us are thinking more in terms of, like, heterogeneous clusters and trying to utilize them to their fullest extent, or even just trying to add more granularity image selection to take advantage of additional hardware capabilities. I think Brandon was next.
Yeah, the hands came quick, so it was hard to keep track. You made most of my point for me, which was that I think when we're getting into image selection, you get that default image that you can fall back to, and that changes this very dramatically from if we are trying to do a compatibility on a single image. And so we get around a lot of those issues where, yeah, you can still run this thing on a machine. It'll just fall back to one of the more generic images. That works good. But I want to be careful that we don't create something that will generate images that users just wouldn't be able to run. That's my biggest concern. I don't want us to start generating stuff that says, here's the image that requires all this stuff, and you cannot run it because you didn't pass all these checks when the user could run it. They just have a laptop that's a little bit older, and it might just be a little bit slower for them. So node selection for them just isn't there. They have the one node they've got. And then how we extrapolate from that to the big Kubernetes clusters where we need to find the best node, that becomes a very difficult problem. because I don't know how we equate that this one image might have a whole bunch of different targets, some of them better than others, but how do we know how much better it is and which one's the good one to run on? All right, I've rambled on enough. Patrick, go ahead.
Yeah, I mean, I think a lot of things were actually said when all the other hands were raised. But I was also then noticing that actually if you do start to run with a CPU instruction set that would be optimal for your platform or not, you have to be really careful when you actually compile the application, because I mean, if you compile it with like optimizations for fairly new Intel processors, it's going to run on those, and then somebody throws in a little bit older generation of CPU, and then everything just stalls in a disastrous way. Which also means that yes, now you need, even after this discussion, you need to start to think about that. How did you compile your code in the first place? But that's a little bit beyond this. But yeah, this sounds a little bit. It would be great if you could express what Marcin wants, and then sort of have the spectrum to Vanessa, who has one specific application for a specific set of nodes in mind, and then everybody else that actually they are fine that it just runs and produces output.
Okay, then I will go next in that case. So we don't want to even allow this for feedback, not for feedback, sorry. We don't want to allow this even optionally because we don't want to tempt users to or open some gate for undesired behavior, how users treat that. Jorn is basically right. I'm coming from the different angle that we have very specific and restricted environments and requirements as well. So that's why I wanted to go with that optionally, right? That you specified as graph relations. However, if I take from your feedback that we don't want to open this gate for the users because we are afraid that we don't know where it is gonna go. Like people will be overusing this. Correct? Okay. So I would say, yeah.
Today, we've already got people that are saying, hey, I know this was compiled for AMD 64 and I'm on a Mac M1. Let me run it anyway.
Okay.
And with all the what's the QMU and interpreter stuff that they can do, they can run it. So it doesn't even have to be optimized for their machine at all. It doesn't have to be compiled for the same platform for them.
I see. Okay. In that case, to make this very official or something like that, I would just call for voting, right? That we want to exclude this kind of graph stuff in the specification, that they can take this and discuss with Huawei folks how we can do it differently or so. I understand that all of you are against that unless somebody is 1, 2.
I thought
Wait,
Vanessa
are we
was the big
voting?
graph fan.
What are we voting for?
To not have graph in the spec.
Yeah, I would not like to have a graph directly in the artifact. My desire is to have an external schema link that is optional, does not have to be seen, but is for advanced use cases, but not directly in the artifact here.
Or I guess I like the simple expression language idea of it's not hard to write a parser for. Like we have it in Swarm, it's like 80 lines ago. It's very similar, but also, another option I guess would be like if you really do like the graph, I think coming up with tooling to generate it so people aren't manually writing these graph expressions in JSON would be essential. Like there should be a standard expression language and tooling. I think the main thing for me is like if this is the direction that people go, maintaining those graph relationships by hand is just really awful and fraught, and it should be generated. But
So
I'd say I don't like the graph asterisk if it's written by a human.
If it's written by human, okay. I just wonder about some alternative. If we have artifact and we have a blob with this JSON, which is very simple, and you have some additional content that you express the graph, even if it's generated by human or
Wouldn't that
automated.
just be the external schema then? Like, you just use that one?
Not really,
Yeah.
because the schema again is coming from the interest group, and
Yeah, but
there
it's
is
a URL on the internet. It can come from you as well.
yeah, but you want to how would you distribute that? I mean, in air gap environment, you want to have everything in one place, right? I don't want to have just a URL that shows how everything is put
Well, that's a
together.
separate problem. I mean, like that's a separate problem when if you need to get any
I
kind
mean,
of
you could
URL
have
in an
a,
air-gapped environment.
I mean, you can have a registry, like you can have a registry blob that represents that data where it's pushed to a registry. And so you can, you can have the canonical source as the URL, but then the cached copy that is content addressable in the registry. Like there's, and like, yeah, then you have to pull that related object, but we're already talking about everybody who's advocating for like an artifacts-based approach where it's not all monolithic in the manifest list. We're already talking about walking the graph of OCI JSON objects anyway. So what's one more?
I think we should be voting for if there is a graph directly in the artifact.
Yeah,
Like
yeah, but
that's sort of the point. That's the sort of like, and then based on that decision, then we figure out the details.
yeah, right. I mean, if we are not for that we keep it very simple. I just thought to put additional layer where you specify those graphs and so on. I didn't want to put any references to in the spec in that case to build any relations or to any graphs. Just wanted to have one additional blob with this graph representation or so. But the takeaway from that is we are no for the graph, and Bjorn is saying unless it's generated by human, unless it's generated by some scripts or whatever. Do I get you correctly?
Yeah, mostly that like I mean, I don't think necessarily it's objectionable in and of itself, but I don't think it's sensible as a UI or how people should actually interact with this in the primary case. And simultaneously, like I do wonder if a graph is simply more flexible than is actually needed, because I think what you're trying to express for the most part is actually a matrix, and you have a lot more dimensionality than necessarily you need. And I feel like, at the other hand, like we've all like stubbed our toes on how limiting a 2D matrix can be, like in CI systems and similar, where it's a very common solution to the problem. And like, lots of like little carve-ins or carve-outs that are needed to make a matrix work, certainly over something more expressive. There's trade-offs there, but definitely like the version you have is very open-ended, and there's a little bit of like, I feel like, we might think we can use it responsibly, but in my experience, like you give people something very open-ended and they often use it in very curious ways. Um, and goodness knows, like we've seen this with all sorts of like weird takes on like OCI compatible, which is often just like whatever a registry might accept. And there's some truly bizarre things in there contradicting the spec, but like the registry accepted it. So, um,
I parsed
yeah, I don't
Docker
know.
Hub once and I found all these images that were like full-length movies that somehow someone put in containers. Off-label use case of
Docker Hub
containers.
is free S3 storage with the global CDN in front of it. Don't
Yeah,
tell
exactly.
anybody, but you can just put whatever you want. There's no quotas.
Okay, so I guess that I mean I would just my point out of this is mostly community doesn't like to keep this as a graph, keep graph in the spec itself. And next I'm going to talk with telco guys about some alternatives, how we can do it in a different way.
Yeah, and just to reiterate, like my kind of thought here is I don't think that necessarily like the like optimal versus compatible like are mutually exclusive. Like I think it's entirely like I think that these two can actually be reconciled together in a world where like the way you express like must be strictly compatible is you don't include a fallback image basically, or you don't include a fallback configuration. Whereas for those of us who are simply trying to make sure that like the right hardware gets the rightly optimized version that's, I don't know, compiled for the I don't know, everything from like optimized for a specific NUMA layout to, has a specific GPU to a specific, generation of Intel processor with MArch native, like we have a generic fallback and simply you wouldn't. And then, that would generate a scheduling. I mean, who knows at what layer, because to the sidebar conversation with Nathan here, like at what level should somebody be actioning those? I mean, we're used to doing it in the runtime because people expect to pass a multi-platform image in and just get the right result. Maybe you decide to do that at a higher level. That's hard actually, because you need to then surface a lot of information about the node to make those correct decisions at a high level. And that's something of an unsolved problem in Kubernetes. Like NRI gets us there a little bit, but not all the way.
We're trying to
I don't
work
know.
on
Again,
that.
I don't know what it's like in not Kubernetes. My familiarity here is like all Kubernetes, Nomad.
We're trying to take the
it's
not Kubernetes and bring it to Kubernetes. It's
Yeah,
I do think
but
there's a push for more topology information. But anyway, sorry. Continue.
well, and Kubernetes is adding like resource aware scheduling. I mean, we saw power aware scheduling actually added recently. I want to say in the last year. Like, so certainly, like there is a blurring of the lines between historically where these scheduling decisions have been made. But my point kind of being that like, perhaps the missing link to bridge the compatible versus optimal question is to simply it's the presence of a fallback or not, and then you generate a scheduling error when you want to force strict compatibility because there is no image that is allowed to be scheduled. There is no fallback that's truly generic.
I'm just trying to think of what it's going to look like for the scheduler when you do have that fallback. And so you've got the generic image that runs everything, the NUMA enhanced image that has all this stuff that it needs to do. And the scheduler is looking across the cluster and saying, well, I've got one NUMA node and 15 generic nodes. Which one do I pick? So I'm imagining
there's a
that won't
trade-off
be
between cost, time. I mean, there's
exactly.
the thing is like we consider all of these, we call them different subsystems in the scheduler graph, and it is a really hard problem. I'm definitely going to agree with you there, but I think it's a problem we have to solve, so that's why we're working on it. And it's
Well,
fun.
and again, just to highlight, like again, I know that Kubernetes isn't everything, and that's not all we're discussing here, but like certainly in the Kubernetes world, like that's also where these disconnects kind of happen versus like Marson's or like cultural disconnect, contextual disconnects, like between Marson's example of the really specific hardware. Another one being that like Kubernetes is designed with the assumption of like these very homogeneous, undifferentiated compute that is, commodity and not cheap, not expensive necessarily, but like that like cost optimization and trying to eke the performance out of especially like specific hardware is not really a concern up until recently. That's somewhat being retrofitted. And so, it's a very different perspective from like the scientific and HPC worlds where I understand, heterogeneous hardware and trying to optimize your scheduling to get every last flop of performance out of it is kind of the name of the game. Yeah. I mean, I don't think it's an irreconcilable gap or not. I think actually these discussions are quite productive to understanding each other's perspectives, but also like it's definitely people have very different contexts coming in.
Yeah, I totally agree with that. Yeah, and I understand that. So, but it's gonna be fun in the next few years because telco is really coming to Kubernetes, and I expect there are a lot of frictions because telco use cases are very, very specific, and sometimes they are a little bit slow because of the SLA agreements or QLA agreements, and the think that they have to provide very high quality. They are not so fast. And there is also the discussion initiated in Kubernetes world today about LTS version for Kubernetes that people doesn't like as well. But telco cannot follow with the upgrades because if you have data centers with like 1,000 nodes, you do one upgrade and another day you have to start another one. So it's going to be interesting to see all of this stuff.
Oh, this is already like the like release cycles in the Kubernetes world are another very painful discussion. I've talked several times with Mike Brown about his like pet peeve of, so this feature is in Kubernetes in alpha or beta, but I can't use it at all because like my cloud provider ships containerd 1.6. So like I can't use this feature with Kubernetes 1.28 that's supposed to be experimental, but I can try it out because the underlying runtime doesn't support it. So we should just backport everything in containerd 1.6 because Kubernetes, yeah, no, those discussions are far ranging across the ecosystem. Like you've only scratched the surface there. And a lot of people feel very strongly.
Yeah. Okay. So I guess we are out of time. Thanks, folks. That was good discussion, and I could have some good input. Okay, thank you, and talk to you the next week.
Yeah, well, tomorrow we'll see some of you tomorrow.
Yeah, tomorrow.
Remember, ping Marcin if you wanna join. Okay.
Bye.
Bye, everyone.
Bye bye.